Okay, we are on the third week, the skeletal system. And this is the axial skeletal system. And the part that I'm going to be doing is the vertebral column and rib cage. This whole section right here. So where it says the skull, those are going to be your bones that you need to look up, all right? And on the top of page 24 or 32, depending on what manual you have, be able to locate these 5 sinuses and these sutures, okay? The coronal, lomboidal, sagittal, squamosal. One of the things that will help you do this is in your book, find the skull, highlight the bones that you're supposed to know from your lab manual, and then as you're studying these, you can take a sheet of paper like this and you cover them up and you go, ah, that's the frontal bone. The next one is the sphenoid, then the ethmoid, lacrimal, okay, nasal, zygomatic bone, maxilla, mandible. You can even do it in the real pictures of the skull. These are the same bones that you found right here. Okay, so I suggest that you look at that. You also have an atlas like this, and you can highlight the different bones that you are required to know, along with bones of the spinal cord, which we're going to go over tonight. We're going to look basically at a general vertebra and general characteristics, and you can find those characteristics on page 24 or page 32. So we're going to go over all these right here. All right. First, if you're following along on page 24, page 32, the vertebral column and rib cage. A general vertebra, rough drawing of a general vertebra. You start right here with the body, also known as the centrum. There are 3 different types of vertebra. These 3 types of vertebra are the lumbar vertebra, and you can see that their body is very, very large. You have a thoracic. As soon as I grab it, thought I'd grab my thoracic. This is my thoracic vertebra, and you can see that its body is very small. And when you deal with a cervical vertebra, the body is even smaller. Okay? Next structure that I'm going to go over is this process in the back. It is the spinous process, and that is in the posterior position. The body is found in the anterior position. So that is your spinous process, also known as the dorsal spine. Okay? You have two processes out here. Transverse and another transverse process. You have this big hole right here, and that is the vertebral foramen. Vertebral foramen. Now the word foramen simply means hole, and the vertebral foramen is where the spinal cord actually moves up. So basically this pencil acts as the spinal cord, and that would be, this whole area here would be the vertebral foramen. Same for a thoracic vertebra. Spinal cord traverse through there. I need to point out again that the spinal cord doesn't quite make it all the way down to the lumbar vertebra. Okay. The spinal cord itself terminates well before L5 there. So now that we know the word foramen, we have two holes that are on our transverse process. So with common sense, we would call this the transverse foramen with an asterisk. Okay, so why did I put the asterisk there? Asterisk is there because only one type of vertebra has transverse foramen. In other words, that would mean that that vertebra has three holes. And in case there is a cervical vertebra with three holes, another cervical vertebra with three holes. Okay? In fact, that's one of the ways that you can identify a cervical vertebra. Now, you may notice that we left out a couple things here. We left out inferior articulating process, we left out superior articulating process, and intervertebral disc. Okay? Intervertebral disc. Let me erase what I have going here. Intervertebral discs are this band of cartilage that's found in between each vertebra. It is a band of fibrocartilage that is able to withstand tremendous amounts of compressive stress. So these are your intervertebral disc. They're inter, meaning between vertebra. Okay. Whenever you hear about a slipped disc, this is what happens. Obviously, this spine is nice and erect, but if you were to lean on one side, you would compress this disc, and it might even just pop out. But when it pops out, it has a tendency to push up against one of these spinal nerves, and that's the pain that you would feel from a bulging disc or a slipped disc, if you will. All right. Superior articulating process and inferior articulating process. If I take a spinal cord right here, and I've got my cervical vertebra up here, and then I have my, just below that, my thoracic vertebra. Notice that they are stacked one on top of the other. They're stacked one on top of the other. This allows, here is C1 and here is C2. C1 has these little flat spots right here. It goes like this. These are the superior articulating process. Something sits on top of these two flat spots, and this is where they articulate or where they join. It happens to be the skull that actually sits right up on top of this. But if I look on the bottom, there are inferior articulating processes. That means another vertebra, C2, fits right there. In other words, we say that C1 articulates with C2 via C1's inferior articulating processes articulating at C2's superior articulating process, like that. And so we have it, vertebra is stacked on vertebra. On the top of the vertebra are superior articulating processes, and on the bottom are inferior articulating processes. And so with this vertebra, its inferior articulating processes articulate with this one's superior. So that's why every vertebra has a superior articulating process and an inferior articulating process. At least all the ones that we're going to be shown. Obviously, the fifth and last vertebra is probably still going to articulate, more than likely. It articulates down here. Here's L5, and here is the sacrum. So it still has an inferior articulating process to articulate with the sacrum. All right, so that covers, if you will, all the general features of the vertebral column. Let's start looking at the three types of vertebra. The three types of vertebra are cervical vertebra, outlined on page 24 or 32. Cervical vertebra, there are three that we need to be aware of. One is called the atlas, the next one is the axis, and we also need to know about transverse foramen. Well, we already learned about transverse foramen. Transverse foramen are found in the transverse process of the 7 cervical vertebrae. So only cervical vertebra have transverse foramen. Let's show you what atlas and axis look like. Atlas is this guy right here. Big giant hole because this is where the brain stem, not just the spinal cord, but the brain stem is actually going through this big giant vertebral foramen here. Okay? And of course, we already know that the skull sits on top of the axis like this. And with C1, we call it the atlas because if you remember, Atlas is the person that holds up the world. C1 is holding up your world, the skull. Just like this. And it turns out that it is the 2 articulating process on the skull that articulates with C1 below that. We actually need to fill that in. So if you can turn to page 25 or 33, we have a box to fill out. And that box says the structures that join to form the temporomandibular joint. And we're going to talk about those in just a little bit, so as not to get you too. We'll just go fill this in real quick. The structures that join to form the temporomandibular joint are the posterior condyles of the mandible and the mandibular fossa of the temporal bone. Let me go ahead and show you that really quickly. So here's the mandible, the lower part of your jaw, and in the back right here, at my two fingers right here, my thumb and middle finger, those are the posterior condyles because they're found in the back. Those posterior condyles fit right in these two holes right here. And those two holes right there, those are referred to as the mandibular fossas, because it is the mandible that fits into those fossa. Fossa is a depression. So we got these holes right here, and the posterior condyles fit right in it. So these fossa are part of the temporal bone. Here's the temporal bone, here's the temporal bone, and the fossas are right there. Okay? This forms the temporomandibular joint, TMJ. Okay. The other square on page 26, the atlas articulates superiorly with the occipital condyles. So fill that in. The atlas articulates superiorly with the occipital condyles of the occipital bone. This connection allows the head to go up and down. C1 or atlas allows the skull to rock on top of that. All right? Now it turns out that C1 also articulates with C2. Here's C2. It's unique because it has this little post that you can see in the back. I can hold it like this. That is the dens, D-E-N-S, or the odontoid process. Odontoid process. So the dens slips up like this. The skull sits on top of here, and we call this the axis because it's this bone that allows the head to shake its head no. Okay? It is the odontoid process, or the dens, that attaches and allows you to move your head from side to side, saying no. So C1 articulates with C2. Let's fill in that little box at the top of page 26. The atlas articulates superiorly with the occipital condyles of the occipital bone. The atlas articulates inferiorly with the top of C2, otherwise known as the axis. All right? Vertebral column going down, basically over to the left. You can label these. I'll show you what I did in my book. I simply wrote cervical, of which there are 7. This vertebra is thoracic, of which there are 12, and then 5 lumbar. And this is just showing the superior articulating surface of the thoracic and the inferior articulating process of the lumbar. But it probably wouldn't hurt to show that to you on this guy. And I've got some dots. for us. Okay? The black dots, these top ones, this is the top of that because the thoracic vertebra always has its spinous process pointing down. Okay, it would never be pointing up, it'd be pointing down. So you have two superior articulating surfaces, and then down here, two inferior articulating process. You might be saying, well, what is this green spot over here on the side? Well, I'm glad you asked that. Let me grab a rib. There's a picture of this in your book. If you follow it, find thoracic vertebra. It's not too hard to find. But you have this little transverse process on the vertebra. I'm going to do it like this so you're looking down. This part of the rib attaches right here. And then right here we just wind a bunch of ligaments right around here. And the head of the rib actually articulates at the side of the body of the thoracic vertebra, and that is what we call a costal facet. A costal facet. Okay? So basically we have two smooth surfaces, two different kinds. Superior and inferior articulating process. Then on either side of the body, posteriorly, you have two costal facets. So a question would be very easy. Pointing to this area, say, what articulates here? And you would say, the rib. Or if they say, what is the articulation point? You would say, the head of the rib articulates right there. Okay? All right. I think I get 15 minutes of video time. I'm going to stop it right here. Yep, still going. So I'm going to stop it here and start another one.